closer analysis of those remains, even though they're burnt, we can work out people's approximate ages. We may be able to work out if they're male or female. So it's a really important opportunity to learn about the...
They thought the ashes would stay silent forever. For decades, Stonehenge charred bones were boxed, labelled, and forgotten. The ultimate closed case. But a new kind of isotope testing has pried open those boxes and rewritten what those ancient remains are really saying. Well, that's the interesting point, is that we've done oxygen isotope analysis of his teeth and we've been able to work out where he grew up, and we discovered that he probably grew up in Central Europe, possibly in the Out region. The chemical signatures buried deep inside the skull fragments point to something the official story never allowed for. They tried to hide this not with lies but with neglect, with the quiet comfort of nothing left to learn. We are in the constant process of rewriting the past, and DNA is playing a massive role in that. Breakthroughs in DNA research are contributing to the story, and changing the story is unbelievable. Yet the evidence speaks, and it's louder than anyone expected. Because the moment scientists read the signals in those remains, a hidden network of journeys, fire, and intent started to re-emerge. Stonehenge is still proving that it has plenty of surprises in store. What was hiding at Stonehenge? Isotope tests run on Stonehenge's ancient remains have just revealed the truth that's been hidden for centuries. These aren't ordinary ashes. The mineral traces locked inside them are whispering of landscapes far beyond Salisbury Plain. Some of the dead did not belong here at all. Science just proved that part of Stonehenge's story was never local. For years, experts treated those cremated fragments as closed evidence. Too burned, too fragile, too contaminated to say anything useful. The assumption was simple. Cremation destroys chemistry. Once burned, a person's geographic origin was gone forever. The remains were set to be a part of the long list of mysteries that surround Stonehenge. But recent breakthroughs have flipped that logic on its head. Dr. Christoph Snook, one of the scientists leading this work, described the moment in measured terms. We realized the fire hadn't erased the signature. It had sealed it. Centuries of dismissal collapsed. Cremation destroys most markers for identifying remains. But until recently, no one had considered isotope testing. A skull fragment no larger than a coin holds clues to rainfall patterns, bedrock, and soil types from hundreds of miles away. It's quantifiable, traceable evidence coded into strontium ratios that survive even the fiercest flames. The breakthrough came from an unexpected angle. While most archaeologists were still debating how the stones reached Salisbury Plain, a small team in Oxford and Brussels started asking a different question. What if the cremated remains could tell us who helped move them? The bones had been sitting in storage since the 1920s, ignored, overlooked, assumed to be worthless. No one had bothered to apply modern testing because the textbooks said it wouldn't work. But the textbooks were wrong. Somewhere between forgotten boxes and modern laboratories, a story began to reassemble itself. Pieces stored, re-earied, and recovered decades apart, suddenly aligned like coordinates on a map. Each tested bone became a point of origin waiting to be connected. The first results revealed something unsettling. Either people were traveling to Stonehenge from very far away, or their remains were being carried there after death. Either way, the movement was deliberate and significant. These days, millions of visitors make the trip to Stonehenge. But why were they doing that thousands of years ago? The realization unraveled every easy explanation about Stonehenge is dead. The old assumptions are gone. The new evidence is here. Why these bones were written off until now? For 90 years, Stonehenge's most important evidence was literally buried and forgotten. Not because it was useless, but because everyone believed a lie about cremation. For most of the 20th century, every archaeologist knew the same rule. Cremation destroys evidence. Once bone meets flame, its chemistry collapses. The result is a sterile relic, impossible to analyze, stripped of its story. That single assumption froze Stonehenge dead in time for nearly 100 years. Experts could only guess at the history of the site, the people who had built it, who visited it, and where they came from. Until recently, the tools simply didn't exist. Cremated bone looks like stone, and under early microscopes, it behaved like it. Brittle, crystalline, unreadable. The standard wisdom said isotopes, those tiny variations of elements that mark where someone lived, were wiped out in the fire. We already knew that DNA is obliterated by cremation. So, it made sense that other tests were out of reach, too. If that's true, then Stonehenge remains could never reveal where their owners came from. End of story. Except that the story didn't end. It was just buried under bad expectations. When those remains were first excavated in the 1920s, they were boxed, studied briefly, and then strangely re-buried in the soil near the site. Out of sight, out of funding, out of mind. The technology simply didn't exist to dig deeper into the story. Only decades later were they re-examined. By then, the field had changed, but the stigma around cremated bone hadn't. Researchers focused on graves with intact skeletons because that was where the data lived. Or so they thought. The problem went deeper than just outdated equipment. Academic careers were built on the assumption that cremated remains were dead ends. Entire research proposals were rejected if they mentioned testing burned bone. Funding bodies refused grants. Peer reviewers dismissed papers before publication. The scientific community had created an echo chamber where questioning the cremation rule became career suicide. Young researchers learned quickly, don't waste your time on ashes. Graves and skeletons were where the answers lay. Dr. Martin Smith, an osteoarchaeologist who later reviewed the Stonehenge samples, admitted, "We didn't think you could get anything reliable from burned bone." It seemed hopeless. That hopelessness became policy. Projects were planned around what couldn't be known rather than what might still be hiding in plain sight. For decades, no one even tried. The archive drawers gathered dust while technology advanced elsewhere in DNA sequencing, radiocarbon calibration, and satellite imaging. But no one went back to those scorched fragments, the very pieces that might connect the monument to a larger web of movement and meaning. Around 2015, new experiments began to challenge the old rule. What if instead of erasing isotope signals, high heat actually locked them in? It sounded impossible, but so did every major discovery before it. The scientists decided to test that idea, and what they found next would make even the skeptics look twice. The evidence drawer, what was found and where? 25 cremated bodies, all from Stonehenge's earliest construction phase. And when scientists finally tested them in 2015, the numbers didn't match Salisbury Plain at all. These were the cremated remains that once lay in circular pits at the very edge of Stonehenge, the so-called Aubrey holes. Back in the 1920s, when archaeologist William Holly first dug them, he uncovered fragments of bone too burned to identify. They were buried nearby, a practical decision at the time. There were bigger discoveries to focus on rather than a few fragments of bone, almost burnt away to nothing. Decades later, in 2008, the bones were exhumed again under modern supervision. Some people weren't willing to give up on even the tiniest bits of evidence. Those ashes had waited 90 years for the right question. The team catalogued 25 individuals. Most were adults, some possibly male, some female. Impossible to tell for certain after cremation, but distinctive enough to analyze chemically. They weren't whole skeletons, just skull pieces, bits of pelvis, splinters of long bone. The fragments weighed ounces, not pounds. Yet inside them, strontium and oxygen. Isotopes were waiting. Microscopic fingerprints of ancient geography. Each sample's origin within Stonehenge was mapped precisely. Most came from the Ring of Aubrey holes, the circular pits dug thousands of years before the towering Sarsen stones were raised. Those holes are among the earliest parts of the monument, possibly dug when the blue stones from Western Britain first arrived. It's this very early history of Stonehenge that has evaded historians and archaeologists for years. No one expected cremated remains to hold the answers. But now people were starting to ask, if the stones had traveled across the island, could the people have done the same? Professor Mike Parker Pearson, who led the renewed excavation, described the moment of realization. We weren't just looking at cremated bones. We were looking at people who took part in the earliest stages of Stonehenge's creation. These weren't random burials scattered through time. They were deliberate placements at the monument's beginning. The bones were cleaned, labeled anew, and shipped to specialized labs for isotopic analysis. Every fragment represented an opportunity to connect chemistry with movement to find out whether these individuals lived and died near Salisbury Plain or somewhere else entirely. The answer wasn't what anyone expected. The numbers started pointing beyond Wessex, beyond the horizon of what had once seemed possible. But before those results could mean anything, scientists had to prove one thing. That fire didn't destroy the evidence they were about to rely on. How isotope science reads a life from ash. Every landscape carries its own chemical fingerprint. The soil, the water, and the plants all hold unique ratios of elements like strontium and oxygen. When a person eats and drinks in one place for years, those elements quietly build up in their bones and teeth. Move far enough away and your chemistry changes. Even after death, your bones remember where you've been. It's a fascinating internal map that we never get to see in ourselves. The challenge with cremation was always the fire. Temperatures above 1,000 degrees Fahrenheit were thought to destroy those delicate traces. But new research flipped that belief. Instead of erasing isotopes, the heat actually locks them in by changing the bone structure. Under a scanning electron microscope, the crystal lattice inside burned bone tightens, sealing off contamination and preserving the signature for thousands of years. It's the kind of technology that didn't exist when the cremated remains were first discovered, and the kind that many believed wasn't as good as DNA. These beliefs and limitations kept the truth hidden for centuries. Dr. Christoph Snoke ran a bold experiment. He cremated animal bones under controlled conditions, then compared their isotopic readings before and after burning. The results shocked everyone. The strontium ratio stayed stable. The fire, Snook said, doesn't delete the data. It encrypts it. That single finding opened a door no one had dared to touch. Suddenly, even ancient cremations could be analyzed. For Stonehenge, it meant the once mute ashes could finally speak. The process itself is remarkably precise. Scientists drill micro-samples from the densest part of each bone fragment, usually the petrous bone from the skull, which is the hardest and most protected from contamination. These samples are then dissolved in ultra-pure acid inside sterile lab conditions. The resulting solution passes through a mass spectrometer that can detect isotope ratios down to parts per million. One fragment the size of a grain of rice can reveal an entire lifetime of movement. Each of the 25 bone samples from the Aubrey holes was powdered, cleaned, and dissolved in acid for testing. The strontium isotope ratios were then matched against reference maps of British geology, comparing every possible origin from chalk plains to volcanic hills. Oxygen isotopes taken from phosphate in the bone added a second layer: climate, rainfall, and humidity. Together, they formed a chemical map of a person's last decade of life. The method also revealed details about the pus themselves. Carbon isotope analysis of the wood residues showed different fuel sources: oak, ash, and in some cases, species not native to southern England. That clue would become critical later, but for now, it was just one more anomaly in a data set already defying expectation. By the time the last test tube cooled, the team had numbers that didn't fit the local pattern at all. Some of those ratios pointed somewhere else entirely, to rocks far older, hills far wetter, and a distance too great to ignore. The patterns, locals, outsiders, and a long-distance link. 15 bodies matched local geology. 10 didn't. Their chemistry pointed to rocks 200 m away in a region that would soon become impossible to ignore. Roughly 15 of the tested individuals showed chemical signatures that matched the chalk geology around Salisbury Plain. They were the locals, the people who lived, ate, and drank within the same landscape where Stonehenge still stands. Their isotopic readings lined up neatly with the region's groundwater and vegetation. No surprise there. But the other 10 didn't fit. Their strontium values were far too high. Their oxygen ratios too low for southern England. The readings pointed to older rocks and wetter climates, conditions found not in Wessex, but in the far west of Britain. The bones carried the imprint of places hundreds of miles away. That meant movement, and not just of stones. These non-local signatures lined up eerily well with the geology of Western Britain. Carbon isotope checks on the PY residues showed differences in the wood used for burning. Some cremations had fuel traces from dense western forests, not from the lighter oak and hazel common near Salisbury. At least some of these people were cremated elsewhere, their ashes later transported to Stonehenge for burial. Someone carried them here across rivers, hills, and entire tribal territories. 5,000 years ago, that was no easy feat. The date range of these remains stretched back to the monument's earliest phase between roughly 300 and 2500 BCE. Over centuries, the same pattern repeated, a mix of locals and outsiders, a constant exchange of life and death between regions. This wasn't a one-time event. It was a relationship maintained across generations. Every data point tightened the puzzle. Who were these outsiders? Why bring them here? And what connection bound their homeland to this circle of stones? Possible motives: ritual, pilgrimage, or political claim. Why would anyone carry the cremated remains of the dead across nearly 200 m of rough prehistoric terrain? The isotope results didn't just raise that question, they demanded an answer. It's long been known that the stones used to create the stone circle aren't local, so migration of people also makes sense. What's unknown is the why. Why use rocks in people from hundreds of miles away? Why transport the dead? For archaeologists, three main possibilities emerged. None were simple. Each could change what Stonehenge really was. The first theory is ritual pilgrimage. Some researchers believe Stonehenge was a sacred destination, a final resting point where the dead were brought to complete their journey. People might have cremated loved ones in their home regions, then carried the ashes to Stonehenge as part of a long ceremonial process. Dr. Rick Schulting, an Oxford archaeologist, described it this way. It's not just movement, it's intention. The transport of remains would have been a statement of connection. Every bag of ashes was a message written in fire. The second theory is migration and settlement. Others argue that these individuals may have lived, not just died, far from Salisbury Plain. They could have moved in life, bringing their traditions, their stones, and eventually their dead with them. The isotopic readings might reflect the first generation of settlers who migrated from Western Britain to the region, leaving behind both monuments and memories. Professor Mike Parker Pearson has noted that the timing aligns with major building activity at Stonehenge's earliest phase, suggesting waves of people as well as stones. The third theory is political or territorial symbolism. This one carries the most weight with recent findings. Some scholars suggest the transport of cremated remains could have been an act of claiming the monument, a way to merge distant communities through shared ancestry. By burying the dead of multiple regions in one sacred site, leaders could have forged alliances or reinforced power across Britain. Dr. Alastair Whittle, commenting on the findings, said, Stonehenge may have been a gathering point not just spiritually but socially, uniting groups over wide areas. Stonehenge becomes a strategy of connection. The evidence fits more than one model. The isotopes show distance. The wood types confirm cremation elsewhere, but intention remains invisible. Was this about faith, kinship, or control? The truth may lie somewhere between, or in a reason no one has yet considered. The dead weren't chosen at random. Their ashes formed part of an ancient conversation linking places hundreds of miles apart. That connection between the people, the stones, and what they stood for hides the final piece of the story. What the isotopes really show, the truth emerges. The strontium data proved it. At least 10 people buried at Stonehenge came from the Pelly Hills in West Wales, the exact quarry site of the Blue Stones. The stones and the people had come from the same place. When scientists overlaid the strontium data from Stonehenge cremated remains onto Britain's geological map, the result was undeniable. The isotopic signatures were consistent with the Pelly Hills of West Wales, the very region where Stonehenge's blue stones were quarried. Dr. John Poundseat, part of the geospatial analysis team, later commented, "We weren't looking for whales. Whales found us in the data." His words captured the shock of the result. Chemistry alone had redrawn the map of Stonehenge's population. That single overlap rewrote one of archaeology's longest-running assumptions. For decades, the idea that people and stones traveled together was speculation, poetic even. Now it had chemical proof. The isotope test didn't just hint. They confirmed that some of the dead interred at Stonehenge had once lived and likely died in the same far western landscapes that birthed its earliest building materials. Dr. Christoph Snook called it a fingerprint match between human and monument. The chemistry aligned too precisely to be a coincidence. The carbon evidence was even more striking. The PY wood used for several of the non-local cremations matched species native to the wetter forests of western Britain, not the drier oaklands around Salisbury Plain. These individuals were likely cremated in Wales, their remains carried across nearly 200 m to be buried at Stonehenge. Someone made that journey not for trade, not for conquest, but for memory. The implications are enormous. Stonehenge wasn't an isolated local monument. It was a work landmark binding distant communities through shared rituals of life and death. The transport of both stones and people speaks of enduring relationships, cultural, spiritual, maybe even political, between regions long before written history. They tried to hide this simply because these ashes sat ignored for a century. Their truth locked in because no one thought to ask. The silence wasn't deliberate, but it was costly. If the bones hadn't been tested, we'd still be telling the wrong story. By uniting chemical evidence, burial context, and regional mapping, researchers finally pieced together what the monument was built to express. Connection. The people who brought the blue stones didn't just move rock. They moved their dead, their identity, and their meaning. Stonehenge isn't just about where the stones stand. It's about where its people came from and the invisible journeys that built it. What this means for Stonehenge and for you. Stonehenge wasn't just a monument of stones. It was a monument of movement. People, ideas, and ashes traveled hundreds of miles to meet on that plain. For every block of blue stone dragged from Wales, there may have been a life carried beside it. Someone's parent, leader, or companion whose remains became part of the circle itself. For archaeologists, the isotope breakthrough is more than a single discovery. It's a new tool. Cremated remains, once dismissed as unreadable, are now archives of mobility, culture, and exchange. Similar methods are already being planned for burial sites across Europe, from Ireland to Brittany. Each test has the potential to redraw another chapter of human movement that's been invisible until now. The implications reach beyond Britain. Cremation was the dominant burial practice across much of prehistoric Europe and Asia. Millions of cremated remains sit in museums and storage facilities worldwide. All previously written off as unreadable. Now every single one is potentially a window into ancient migration, trade networks, and cultural exchange. Entire civilizations that practiced cremation from Bronze Age Scandinavia to Iron Age Italy can suddenly be traced with the same precision we once reserved only for intact burials. Dr. Mike Parker Pearson put it simply. We've been looking at the stones for a century. Now we can finally look at the people. That shift changes how museums, historians, and even visitors approach prehistory. The story is no longer fixed in place. Every fragment of bone could connect two regions, two lives, two ancient communities. The idea of a static Stone Age of small villages living and dying in isolation no longer fits the evidence. They weren't isolated. They were connected across landscapes, across generations. We might never fully understand why people traveled hundreds of miles, why stones were dragged, and why people followed. But we do now have a map inside the tiniest of fragments that shows how our Neolithic ancestors traveled, built connections, and built monuments that still have us asking questions today. The isotope tests on Stonehenge's ancient remains reveal the truth hidden for centuries. That the builders of Britain's most iconic monument were part of a far-reaching network, one that valued connection enough to carry both stones and souls across impossible distances. This discovery also raises modern questions. If connection defined them, what defines us? We live in an age of instant communication. Yet, ancient people with no wheels, no maps, and no written language maintained bonds spanning the length of Britain. They carried their dead, honored them, and placed them in the heart of a monument that still stands. The scientists have done their part. The data is there, and the chemistry speaks. Now, it's on us to listen. Because if the ashes at Stonehenge remind us of anything, it's this. Even in prehistory, we were never alone. If people 5,000 years ago could carry their history across entire landscapes, what distances, physical or human, are we still willing to cross today?